Good evening, team. Welcome back. I'm Corey, and we're about to get started on day 14 of Advent of Code in Rust. Better late than never. If you missed any of my previous days, check out the playlist up top for all my solutions, and don't forget to like and subscribe for more videos. Let's get started. Okay, let's jump into day 14 here. Day 14, Regolith Reservoir. The distress signal leads you to a giant waterfall. Actually, hang on. The signal seems like it's coming from the waterfall itself, and that doesn't make any sense. However, you notice a little path that leads beyond the waterfall. Correction. The distress signal leads you beyond a giant waterfall. There seems to be a large cave system there, and the signal definitely leads further inside. As you begin to make your way deeper underground, you feel the ground rumble for a moment. Sand begins pouring into the cave. If you don't quickly figure out where the sand is going, you could quickly become trapped. Fortunately, your familiarity with analyzing the path of falling material will come in handy here. You scan a two-dimensional vertical slice of the cave above you, your puzzle input, and discover that it is mostly air with structures made of rock. Your scan traces the path of each solid rock structure and reports the XY coordinate that form the shape of the path, where X represents the distance right and Y represents the distance down. Each path appears as a single line of text in your scan. After the first point of each path, each point indicates the end of a straight horizontal or vertical line to be drawn from the previous point. For example, okay, so we have a set of coordinates. There are two paths of rocks. The first path consists of two straight lines from 4, 6, okay. And the second path consists of three straight lines, specifically these ones. Yep. The sand is pouring into the cave from point 500, 0. Drawing rocks as this, air as this, and the source of the sand as this, we get something like this from the puzzle here. Sand is poured one unit at a time, and the next unit of sand is not produced until the previous unit of sand comes to rest. A unit of sand is large enough to fill one tile of air in your screen. A unit of sand always falls down one step if possible. If the tile immediately below is blocked by rock or sand, the unit of sand attempts to move diagonally, one step down to the left. If that tile is blocked, the unit of sand attempts to move diagonally to the right. Sand keeps moving as long as it is able to do so. At each step, trying to move down, then down left, then down right. If all three possible destinations are blocked, the unit of sand comes to rest and no longer moves, at which point the next unit of sand is created back at the source. So, drawing sand that has come to rest as 0, the first unit of sand simply falls straight down and then stops. The second unit of sand falls down, lands on the first one, then chooses to rest on its left or right. After a total of 5 units of sand have come to rest, they form this pattern. After 22 units of sand, they form this pattern. Finally, only 2 more units of sand can possibly come to rest. Once all 24 units of sand shown above have come to rest, all further sand flows out the bottom, falling into the endless void. Just for fun, the path any new sand takes before falling forever is shown here with a asterisky thingy. Using your scan, simulate the falling sand. How many units of sand come to rest before the sand starts flowing into the abyss below? Okay, this is going to be a fun one. Okay, so first we're going to parse our input. Well, first let's make a cargo workspace. 14, ooh, this is the fun word that I didn't know how to pronounce earlier. A Regolith. Regolith. Reservoir. War. Wow, that was hard for me. Name is Regolith Reservoir, and it's lib. Okay, let's add it to our cargo workspace. Okay, got a space in there. Let's add a comment at the end. Cargo, let's CD into it now. Cargo run. Bin target. Oh yeah, that's because I didn't want run. I want to test. Get rid of the rust analyzer warnings, and we can run the test. Let's go take a look at the test. It's gonna look like all the others when we start out. Okay, awesome. So let's see. The first thing we're gonna want to do is parse this, and so I think the thing is we're gonna want to grab these different lines as like rock structures or something, and then they're gonna have like line segments in them. Or like these are gonna be the vertices, I guess, and we'll see how I want to translate that eventually. Yeah, I think that makes sense. I don't think that I've got a better idea. And actually, I guess maybe the easiest thing to do, well, I definitely want to parse these as that, but then when I translate it, I might just translate them to the same representation as sand. They're just fixed sand that's not moving anymore for whatever reason. That's probably what I'm going to do. Okay, but I do need to parse this. So we have like a line segment, and we have like a rock structure or something. We're just going to remove all of this for now, I think, and start with an empty thing here. So we've got a struct. I guess let's start this way. Let's start by writing a test. Function. Example input part 1. Let input equals include string. I haven't done one of these in a while. Example input. Let answer equals part 1 of the input, and assert equals that the answer is, and I think the example answer was 22? 24. Okay, and then everything's mad because nothing exists. Example input, and into our example input we get this. Okay, and then, okay, awesome. Now we can, yep, we have example input. We can generate this method. Part 1 is gonna go outside the test. Awesome. And it's gonna return like a U64. That should be fine. Okay, and then let's see, what are the things we want to do with parsing? I said that we had something like a line segment. Well, actually, I guess those are coordinates, right? We have like a coordinate, which let's just do it as a tuple. I don't think I need it to be named with X and Y. Okay, and then I have like a rock structure or something, struct, let's just call it like a line. And this has vertices, which is a vec of coordinates. Okay, so then we can, let's see, and then what do we have here? We have like the maze or something. I don't know, struct. The maze or something has some rocks which is a vec of lines. I'm not sure if I like the naming here. Because it's not a line, it's like a, yeah, maybe this is just like a rock structure or something. I guess let's just lean into it. Rock structure. Of that structure. Yeah, I think that's fine. Maze. Okay, so then let's impl for maze. Let's make a function called parse that takes an input string and returns a self. Okay, what do we have here? We have an input that we want to do lines on, and then we want to map those lines with rock structure.parse. Let's generate that method right away so that the type, oh, it's not gonna let me do that. That's okay. We'll do it manually. We'll implement rock structure. We'll have a function parse that takes an input at string and returns a self. Okay, let's just to do this for now, but now the signature here should be better. Yep, it is. Awesome. Okay. So now we have a lines that I can collect it and name it rocks. And then we can just do self of rocks. Awesome, types are happy there. Now this is a rock structure, which is gonna be one of these lines. We need to split it on this and then trim the segments. Okay, so we want to do input split on the arrow, and then we're gonna map over the things and do x dot trim. I think it's trim. Yep. And then we're gonna map over them and do coordinate parse. Select that. Call that vertices. And do self vertices. That method doesn't exist. Oops, no panic. Impl coordinate parse input string returns a self. Okay, input dot split. Cat toys flying around. And then we're gonna map it where we're gonna do parse dot unwrap because we know we're always gonna deal with integers here. We're gonna we aren't gonna collect this. We're gonna do let mutable split equals that and do let x equals split dot next dot unwrap. We know there's gonna be two things in here, so we can just do this equals split dot next. I want to try something. I want to see if there's another way to get these out of here. Could I do like let x comma y equals split dot collect? Type annotations needed. Oh, that's fair. Self x comma y. Type annotations were still needed here. No, I don't think it. I just don't think it can pattern match that. I just don't think that's. I think I'm making up syntax. That would be fun though. Okay, so now I can have a parse method, and we can parse all the way through. So we can do let parsed equals input. Oh no, maze parse input debug out parsed, and then we will do the rest of the method. Yes, you get a semicolon at the end. Okay, run the test. Wait a sec, why did it even let me run? Oh, it didn't actually let me run the test. It didn't compile because the debug thing, I tried to call debug, but my structs are not debug. Drive debug. Drive debug. Drive debug. Now I can pretty print everything nicely. Oh, I put it on the impl, not the struct. There we go. Okay, did we parse everything nicely? It looks like it. Okay, so now though, what I want to convert this to is initial rocks. Like I want to write a method on maze. Which takes in a reference to self. And it returns a vec of coordinates. And it returns a vec of coordinates that represent the starting rocks for the maze built from the lines in the vertices. Something like that. Okay, so we have initial rocks. It's a vec. Yep, that makes sense. And so we have rock structure, and I think what we really want to do here is we just want to do self dot rocks dot iter dot map. Sorry. So we're iterating over our rocks, and I think all we want to do is we want to just do the same thing. Like just call a rocks method on this, and then oh, there's a flat map. I think I just want to do a flat map here. We call rocks and then we collect to a vec. I can generate the method up here. This is going to return a vec of coordinates. Can I flatten over that? It looks like it. Just something that impulse into iter. Perfect. Vex impl iter into iter. Okay, so now from our rock structure, we can do that. This has the vertices. Okay, so here though, I want to go to lines because I want to be able to draw the things in lines. I'm gonna actually wait. Can I make this a set of coordinates, a hash set? Because I think here I'm gonna get some duplication, and if I just use a hash set, it's just gonna be easier. Because if I just do the lines created by the vertices, let's draw it here. If I do these lines, like I would do these three, and then I would do these three, and then they'd overlap. And if I just use a set, it'll just not have to deal with the overlapping. So I think we're gonna return a set out of this method here. But that should be easy enough. So we're just gonna do self.vertices, and then we want, I think it's windows. We've used this for other problems. Returns an iterator over all contiguous windows. The windows overlap. Perfect, because I want to do windows of 2. And so then I'm going to get coordinates. So then here what I have is 2 coordinates. I'm mapping over a start and an end coordinate. Oh, need that there. Okay. Windows map. We have our start and our end. Okay, so we want to make a line out of these, but really though, I forgot. We're mapping over the lines. This is gonna give us a vec of coordinates. We want to flatten, so I guess this is just gonna be a flat map again. Flat map and a collect. This just can be a to-do, because now will you compile? Oh. It's an array. I forgot about that. Is there tuple windows? Window tuples now. Windows 2. Okay, so I wonder if that's in. No, it's fine. It's fine. Okay, so we have our array. What do we want to call it? Let's just call it A. It's fine for the moment. We just wrote it to do anyways to get the types to compile. Okay, so now we need to figure out. Let's just write a real body here. Okay, so now we need to figure out if it's a vertical or a horizontal line. If it's neither, I think we're just gonna panic for the moment. And we just have 2 coordinates. We have the start and the end. So let's start equals A at 0. Let end equal A at 1. Okay. Let's do let x diff equal start dot abs diff abs. I think it's diff abs. I think I've done this before. Oh, except this is why it's not auto completing. It's because I need to do it on the actual number here. Is it abs diff? Okay. Let y diff equals start dot 1 dot abs diff end dot 1. If x diff so does not equal 0 and y diff does not equal 0, panic with this line isn't straight and we don't support that right now. We just don't support it. Okay, but then if we have a different case, else if x diff equals 0. So now if just x diff is 0, this means we have a vertical line. I need to figure out which one's bigger, I guess, because that's just going to be the easiest way to loop. Yeah. Let's just do this. Let s, because I don't want to alias over start. So let s equal we have a vertical line, so the y's are going to change. That's why the y's have a difference and the x's don't. Okay, so we want to do start.y.minimum. We want to start at the bottom and let end equal start.1.max with end.1. And then for I in s dot equals e. We need a let coordinates equal a hash set new. We're gonna make this mutable. Coordinates, actually this could just be a vec. This doesn't need to be a hash set here. And then that means that this can just be a vec. I like using the macro there. Coordinates dot push a coordinate of I is the x is changing, start dot 0 comma I. Delete surrounding that. Is that what you're mad about? Why aren't you auto formatting? Okay, the collect flat map. Oh, because this isn't returning anything. Coordinates. Flat map. Creates an editor that works like a map that flattens nested structures. Mapping then flattening. Yep. Okay. And yeah, okay. So I'm not exactly sure why that doesn't work. I actually don't even think I need to collect it though. Mismatch type. Expected struct. Oh, I see. Impl into iterator. Where the item is a coordinate. Now what? Hidden. Oh, I need to do a that. There we go. Can't move. Oh, coordinates just need to be copied. Coordinates aren't big enough to not just be copied around. Awesome. Okay, cool. Now we can push the coordinates here. And then we need another one of these for like the other case. Else, this is a horizontal line. It's basically the same thing here, except these all become zeros. 0, 0, 0, 0, and this is flipped. We change the x and we keep the y the same. Okay. Then we return coordinates every time. Awesome. Okay, so I think that's gonna give us our rocks down at the bottom. And we don't really, I think I can maybe just count how many there are here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so there's 20. So let's just see if that comes out right. So let's get a parsed, let's do another test. We just want another one. Okay, test rocks. rocks. Example, let parsed equal maze. Parse the input. And let's do parsed dot initial rocks dot length. And we want 20 of them. And the test says, oh, it needs to be cloned to be copied. That's fine. Okay. Ooh, 23. Oh, that looks like the duplicates didn't get sorted out. This should just be the thing that's a hash set. Oh, why is this mad now, though? That feels like that should be able to compile if the other thing compiled. Oh, to be able to put coordinates in a hash set, they need to be hashable. Hashable needs equal, and I think I don't think I need order and partial order for this one. One passed, one failed. Okay, awesome. So this one should be passing. Great. Okay, so it looks like we are parsing the rocks correctly. This doesn't return a vec anymore. Cool. This is like each line is this map, so like I could really extract this to a method about lines, but I didn't. And okay, awesome. Okay, so now we have the initial rocks, and so now what I need to do is figure out a structure that works for like each piece of time, and I think it's just going to be based around having a set of coordinates, or do I actually just want a coordinate grid of some kind? I probably just want a coordinate grid of some kind. That doesn't sound crazy. It's gonna be a little space intensive just because we're talking about numbers in like the 500s for these examples, but like that's not crazy either. I could always like shift the things or do fancy things with the indexes. But I'm also not really building this to be super fast. So, okay, I'm getting ahead of myself. Let's make some structures. So I think, okay, so what I'm thinking is I want something like a struct for like a frame, which has like a turn number in it maybe. And then it has some moving sand, which is a hash set or something, I don't know, hash set of coordinates. And then we have stopped sand is a hash set of coordinates. Yeah, maybe that's okay. I think that actually probably is okay for now. Okay. Yeah, okay, so we have a frame, and I want to impl from a maze for a frame. I think that's the one it wants me to implement usually. Oh, 4. Change your own word for frame. Implement it. Okay, so if we have a maze, we can do self turn is 0. That's just where we start. Moving sand is oh, I forgot, we do sand one at a time. There is no like moving sand. I was thinking when I was reading the description how I was thinking it was gonna go is we're gonna have a moving sand like every turn, but they have sand move one at a time, so we just don't have that. So like this is really just like rocks, I think. There is no moving sand, and we have a turn. And then so then I can just do value.initial rocks here. Cool. Nice transformation, nothing super exciting. But then I think what's going to be fun is the logic here. So impl frame. We're going to implement a method. Oh, not implement. We're going to have a function called next that takes a reference to self and returns a new frame. And that's going to be like the whole logic here, where a frame is a piece of sand, I think. So like we're going to drop a piece of sand, then we're going to drop this piece of sand. Yeah, okay. So where are we dropping the sand from? I think it's just a static position, right? Static position. Does it just say? The sand is pouring from the cave at point. Yeah, so I think we just say this. Constant sand start. It's a coordinate. 500 0. And I guess. Oh, and oh, okay. The coordinate system starts here and goes down with the Y's. Okay, that is good to know. I was gonna get my numbering backwards at some point, but I haven't done anything with numbering yet, so I wasn't wrong. Okay, so we do let I don't know, I think we want like a mutable sand to be, we start at the sand start. And then while sand dot can move, or like while let some equals sand dot move. So while next move or something. Next move, yeah, just to get rid of the move, because move's a reserved word. Okay, so we're gonna have sand, which is just gonna be a coordinate, have a next move method. That seems reasonable. While we have some sand, I think we just wanna keep going, and when you don't have a sand, that's you're done now. So now rock, we just do let new rocks equals self.rocks dot clone. This needs to be mutable. New rocks dot push sand. And then we return a frame of turn is self.turn +1, comma, rocks is new rocks. Next move doesn't exist, and we can't push to this hash set. No method push found the hash set in current scope. Why can't we push to this hash set? It is mutable? Yep. I think it's something with the things that it implements up here. Oh, I don't know. Yeah. Hash partial equal. I don't know what other ones you would need. Hash set push rust. Push. Oh, is it not push? That would also be why it's not working. What's the insert? Insert. There we go. Okay. Next move doesn't exist. Yes, I know. Oh, next move though needs to know about rocks, which is a hash set of coordinates. No, it's a reference, but yep. Reference to the hash set. Okay, so then let down equals self dot down, which is a method that we don't have yet. Let's write this method. Oops. Ah. Okay, there we go. Generate this down method. it returns another coordinate. Self, where it's self.0 and then self.1 plus 1. Okay, so then if rocks dot contains down, if it contains down, if it doesn't contain down, then we do sum of down. Else if the rocks contains left, it's just self down and left. Then we, oh, I guess I do kind of want to save it. Let down left equal down dot left. Oh, that's kind of cool. Let down right. I only have to do those directions. Generate. Left is gonna go in the minus direction this way. And right will go in the positive direction. Okay, so if that doesn't contain this, if it doesn't contain down left, then we return down left. Else if the rock contains down right, we do some down right. Else we return none. These all just need references. Oh, wrong place. Right there. And right there. And right there. Awesome. Okay, so next move is used. Awesome. Okay, so if the next move, okay, so then here though, next might not return a frame. If we can't have a frame, if this is the final frame and it's the final frame, oh wait, when would it be the final frame? If next move, oh yeah, this might infinite loop right now. This is gonna infinite loop at some point. Once we've like cleared all of the sand pieces. So like there is an infinite loop here if the sand falls forever. But if we can say for sure the sand is below all rocks, we know it is going to keep falling and can be done. Okay, so so what do we have here? We have a frame, which means we have all the rocks. So if self dot lowest rock y, and the y is going to be positive, it's going to be weird. If sand dot y is greater than the lowest rock y, then we can just return out of this whole thing with a none. This doesn't exist yet, oops, but it can. This is just gonna do like a U64, whatever's in the coordinates. Self dot rocks dot iter dot map. Oops. I kind of liked that. I just didn't like having it on the multiple lines like that. So we have an R, and we can do R dot y dot min. I'm gonna say that we just unwrap here because I want it to. Y is the first one, or not the first one, the numeral 1 1. Oh, same thing there. Oh, this is a sum here. Lowest rock Y is used by next. Okay, and the question just is how many pieces of sand fall, right? After a total of 22 units, finally, 2 more can fit. So how many work? Okay, so the answer is going to be... Okay, so then let current equals parse.into. This is a frame, and it's mutable. That's where the from is going to come in and going to convert when we call into here. And then while the let sum f equals current dot next. So while we have a next frame, we're just going to set it equal to that. Open let mutable count equals 0. Count plus equals 1. Count. Okay, let's see. Now let's make part 1 public because that's going to get rid of everything thinking it's not used. Where's part 1? Way up top. Not way up top, in the middle. And, okay, we got... Probably not the right answer. Ooh, we got 0. That's fun. Why did we get 0? Okay, so part 1, count is 0. The frame, while there's next. Oh, okay, so it looks like we just didn't get any. Oh man, my eyes are watery. Sorry, team. Yeah, Bobby. Sorry, talking to my cat. Okay. Why are we getting a 0 here? I'm assuming we're not getting into this. Oh, frame's not going to be debuggable yet. Derive debug. Oh, yep, it had the whole thing there for me. Make it big for the moment. Yeah, we don't get in there at all. Okay, so that doesn't make sense, but that's okay. Next. Wait, where was that? Oh, that was in part 1. Yeah, that was in the part 1 method. Way up here. Okay, so I guess I want to see what this frame looks like. Just because I think I need to start with that. Yep, that looks sane. So it says that the... Oh. I forgot that my Y's go in a weird direction. So I actually want if, yeah, the greater than here, and this is the max, not the min. Okay. Oh, yay, now we get the right answer. Okay. Let's get rid of the debug that I just added. Both of them. That one. Awesome. And let's copy this over. Oh, just make a new test for our my input. My input. Let's grab the my input. That's some puzzle input. Paste my input in, go to my back to here, change this to my answer won't be 24, but it'll be okay, so okay, so it took a while, but it did work. 961. And is it the right answer? Awesome. Okay. I have a feeling that part 2 is going to be a bit more difficult, but I think we're going to save part 2 for another video. We're coming up at an hour, and I think I want to keep these videos at about that length. So I think we are gonna stop here at part 1. But thank you everyone, and come back tomorrow hopefully for part 2. Thanks. Bye.